On today's episode, in this aerospace market, electric is really taking off. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. The electrification of ground transportation is now in full swing, with all major automakers building electric vehicles and charging infrastructure under construction everywhere. Aviation, however, is expected to lag motor transportation for some time, and the reasons are purely technical. Batteries are heavy, and unlike aviation fuels, electricity, when used, doesn't lighten the aircraft, resulting in a landing weight that's the same as the takeoff weight. Now, keeping batteries small and light enough for practical use means aircraft that are small and have limited range. But there are advantages. Aviation fuel is very expensive. Electricity, of course, is not only cheap, but it's universal. No one ever had to develop special electrons to power aircraft compared to motor vehicles. Another major advantage is maintenance cost. Even small general aviation piston engines cost tens of thousands of dollars to overhaul, and engine life is a major per-hour operating cost. Electric motors are subject to inspections, but are in most ways maintenance-free. The same is true of batteries. Electric aircraft are also quiet, which can be a consideration where operators are close to residential areas, and of course, they have a minimal environmental impact. But what aviation market wants light aircraft with limited range, even if the operating economics and environmental impact are favorable? Now, the logical market is training. The nature of training is extensive operation of light aircraft, usually taking off and landing at the same base with some limited cross-country flying. General aviation uses like training are more likely to take place at facilities which are near residential areas as well, and the economics of the industry require low operating costs and high availability rates, both of which are offered by electric aviation. Now, a new generation of airframe manufacturers are racing to fill this market, and one of them is Denver-based Bye Aerospace. That company has developed a small two-seat electric aircraft for the general aviation and training markets, the first of several battery electric aircraft, including a high-performance twin. The trainer, called E-Flyer 2, is a clean-sheet design made of carbon composites, in which the company claims has twice the aerodynamic efficiency of a conventional piston-powered single. The elimination of the need to flow air around the cylinders for cooling is a significant advantage, and combined with the highly laminar flow possible with modern composite construction and a small wetted area, the aircraft is relatively high performance, cruising at about 100 knots at 10,000 feet with a 1,000 feet per minute rate of climb with a 450-pound instructor and trainee with a range at economical cruise of 220 nautical miles. It has an absolute flight endurance of some 3 hours at 73 knots. The Safran electric motor is rated at 150 horsepower maximum, and the exact details of the lithium-ion battery have not yet been revealed by the company. Now, important for a trainer, the stall speed is a modest 48 knots. The aircraft's equipment includes Garmin avionics and a whole aircraft ballistic parachute recovery system. This airplane is flown and is currently under the FAA certification process under the new FAR 23 Amendment 64, which the FAA intends to allow straightforward certification of electric aircraft under the normal category. Now, Bye Aerospace has a current order backlog that the company declares has over $1 billion in value, and significantly, Aviation Week has reported that the company has signed letters of intent with 4 flight schools for a total of 340 aircraft. Now, Bye Aerospace has declined to name the customers. The company, however, is in a strong position to become a major player in the training market. The aircraft is well along in the certification process and has a large order backlog from existing operators of training aircraft. And it's a product whose performance characteristics are uniquely suited for the training mission. The development of more advanced aircraft, however, will require significant financing. And if the E-Flyer 2 is a hit, the major airframers that build the general aviation aircraft that we have known for decades will likely be interested. We'll be following developments. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.